Welcome, Chuck Solution, Loci complex numbers, lesson 5. Right, so today we want to deal with loci which involve arguments. Right, so let's look into this one. We're saying arg of z minus z1 is equals to theta. This represents a half line which makes an angle theta at z1 with the horizontal line parallel to the real axis. Right, so let's see how it looks like on the Argand diagram here. Right, so we need our point z1 here and the horizontal line which is parallel to the real axis here. Then from the point here we need an angle of theta. Right, so this is our angle theta here. Right, so let's go to the example here. Sketch on the Argand diagram arg of z minus 2i is equals to pi over 4. Right, so the first thing is to effect a negative, so it's going to be arg of z minus 0 plus 2i is equals to pi over 4. Alright, so let's see how it looks like on the Argand diagram here. So we are going to go on the point 0 and 2 here, and we need a horizontal line at this point, starting at this point. Then now we want to draw our half line which is making an angle of pi over 4 with this horizontal line here. Alright, so this is the half line here making an angle of pi over 4 here. Alright, so z will be lying on this half line. Right, so we can also find the Cartesian equation of this locus here, right? So let's see how do you find it, right? So we know that z is a complex numbers x plus yi. Z is on this line, right? So we can say let z is equals to x plus yi. Right, so we are going to have arg of x plus yi minus 2i is equals to pi over 4. Right, so now we are going to take the imaginary part here over the real part. So the imaginary part here is y minus 2. So y minus 2 over the real part x is equals to tan pi over 4. Alright, so we can press on the calculator here. So it's going to be y minus 2 is equals to x. Alright, so you can see the equation here is showing from the part where x is greater than 0, x greater than 0 from this side going to this side in the x direction. Then on the y direction we are starting at y greater than or equals to going this direction. That's where the line is showing here. Alright, so that's the condition here. Alright, so remember here we're just saying the imaginary part over the real part is equals to tan angle which is given. Alright, so let's go to the next example here. Alright, sketch on the Argand diagram arg of z less than pi over 3. So this one is now representing a region. So first thing we need to identify our point where we need to draw our half line. So it's going to be arg of z minus 0 plus 0i less than pi over 3. So let's see here. Right, so we are going to plot 0 and 0 I here. So this is our 0 and 0i here. And from this point we need a horizontal line. So horizontal line already is the real axis. Then we need an angle of pi over 3 here. Right, so we are going to draw a broken line because the points on the line on the half line are not included here. Right, so this is the line that we draw, and this is our angle of pi over 3 here. Alright, so now we need the region which is less than pi over 3. So the region which is less than pi over 3, from this line here you can see up here is greater than, the argument will be greater than pi over 3. Then below here the argument will be less than pi over 3. So we are shading this side, right? So let's go to the next example. So our next example, it's sketch on the Argand diagram arg of z minus 2i greater than or equals to minus pi over 4. So you can see here now the angle is now a negative and still it's a region. Alright, so now let's effect our negative here. So it's going to be arg of z minus 2 plus 2i greater than or equals to minus pi over 4. So we need a region which represents an angle of which is greater than minus pi over 4. Alright, so let's go to the Argand diagram here. Right, so we are going to go on the point 2 plus 2i here. So this is our point, and we draw the horizontal line here. So this is our horizontal line. Right, so then from this point we need to an angle of negative pi over 4. So the angles that are up here are positive. If you are measuring in a anti-clockwise direction, the angles are positive. Then measuring in a clockwise direction, the angles are negative. So we are going to draw the angle below here. All right, so it's a continuous line. So this is our continuous line here, because the points here are involved here. The points on the half line are included. All right, so now we need to shade the region here. So you can see that from this horizontal line going to this line here, our half line, it's a negative pi over 4. All right, so we need the part which is greater than minus pi over 4. The part which is greater than minus pi over 4. When we are moving from this horizontal line going to this side, the angle is becoming small. It's going to the negative side. But when you move from this side going this direction, the angle is what? It's becoming g greater than minus pi over 4. So we are going to shade this part. Because from this line, and we try to move this line going back here, you see the angle is becoming greater. So that's the region that we are interested in here. Alright, so let's go to the next example here. Sketch on the Argand diagram pi over 4 less than or equals to arg of z minus 1 plus I less than pi over 3. So you can see now we have two intersection region here that we want to see how they look like here. Alright, so the first thing here is to effect the negative as usual. So it's going to pi over 4 less than arg of z minus open brackets 1 minus I close brackets less than pi over 3. Alright, so we need to break this into two parts here. So let's see here. Alright, so pi over 4 less than or equals to arg of z minus open brackets 1 minus I close brackets less than or equals to pi over 4 can be broken into two regions here. So we are going to have so let's try to read from the center here. So from the center we are going to have arg of z minus 1 minus I less than pi over 3, which is this part here. Alright, so let's try to sketch this one, to draw this one. Right, so let's come on the Argand diagram here. So this is our Argand diagram. Then this is our point 1 minus 1 and minus 1 here, and this is the horizontal line. So from this horizontal line here, we need an angle of pi over 3, but the line is going to be a broken line. So we draw our broken line here. This is the angle of pi over 3. So now we want to shade a region which contain the points such that moving from this point to that complex number, the argument from here to that line will be less than what? Pi over 3. So that's this region here will be less than pi over 3 here. Alright, so this is the region that we are going to shade here, pi or less than pi over 3 here. Alright, so now let's go to the other part here. We are saying arg of z minus open brackets 1 minus I greater than or equals to pi over 4. So this is the one that we write, reading from the center going to the left side here. So it's arg of z minus open brackets 1 minus I close brackets greater than pi over 4 here. Right, so still the same. We go on the Argand diagram, then we go on the central point here, our point that we want to start our half line here. So it's going to be 1 and minus 1 here, and this is our horizontal line, and we need an angle of pi over 4. But take note of the sign here, is greater than or equals to, so which means the point z, the complex z, is also on the half line here. So this is our half line starting from this one. So now we need a region which represent an argument which will be greater than pi over 4. So this angle here is pi over 4, and the part which is greater than pi over 4 is the upper part here. If we move this in this direction, the angle will be greater than pi over 4. So we are going to shade this part here. Alright, so now we want to intersect these two regions here. Right, so we want to intersect this region and this region. Alright, so it's very simple. We are going to have our central point here. So this is our central point 1 and minus 1 here. Alright, so now we need to first draw the two angles that we have here. So we have an angle of pi over 4 and an angle of pi over 3 here. But take note of the lines here, the broken line and the continuous line here. So this is an angle of pi over 3 that we need here, and the region was on the upper part here. Alright, then another angle that we have is an angle of pi over 3. So that region was below here. the region was below here. So we need to intersect here. So when we want to intersect the region above and the region below here, so that's the part that is going to be left here. So we are intersecting at this point, right? So that's the region that is being represented. So thank you for watching the video. See you in the next lesson.